Hello, we are Jae-seok Kim, Yeon-soo Jung, Do Nam-gung from Team 11 in GIS class, and I am the presenter Jong-seok Kim. We carried out the project using QGIS in order to select the best location for electric vehicle charging stations in Incheon metropolitan city. This is the brief index of our presentation. Despite the growing demand for electric vehicles every year, the corresponding electric vehicle charging station is far from sufficient. According to the research, the lack of charging stations for each electric vehicles is the biggest reason for hesitating the purchase of electric vehicles. The need of charging infrastructures is urgent. We proceeded following calculations on Incheon City. Considering the increase in the number of registered electric vehicles, about 31,000 electric vehicles will be in Incheon by 2025. As we targeted 54.3 chargers per 100 electric vehicles, we concluded that roughly 4,436 additional charging stations must be installed by 2025. We made 3 steps. First, we needed to figure out how these 4,436 charging stations should be allocated in each district. Next, we needed to decide where to install the charging station and decide whether there are any additional considerations in order to select the final location. Before working on the project, we collected the following data. As a statistic data, there are registered electric cars, number of living population, and traffic information for each district. As a shapefile, we collected Incheon City map, public parking lot, existing charging station, housing complex including apartment, road, industrial complex, habitually flooded area, and gas station. In order to select the final location, we needed to express 3 things using QGIS. First, referring to the Ministry of Environment's guidelines for installing charging infrastructure, we had to express places vulnerable to floods and salt damage as an inadequate area as a location for charging infrastructure. Secondly, we had to express the intersection of over-demanding areas such as residential areas, business complexes, with areas that are easy for charging station installations. Finally, we had to express places that are in lack of charging infrastructure on QGIS. Our team drew the conclusions on the final location selection using these 3 layers properly. We have allocated 4,436 charging stations by the following steps. We calculated the variable, which is electric vehicle traffic, by multiplying registered electric car, regional employees, and divided it by total number of employees. We distributed the number of charging stations proportional to this variable. The number of separate charging stations distributed is visualized through categorized function after putting it in the attribute table Incheon City map layer. Following picture shows that lots of charging stations needed in Namdong-gu and Gyeong-gu, and less charging stations needed in Ganghwa-gun and Ungjin-gun. The first of 3 to be expressed in QGIS is the visualization process of inappropriate areas. We will name the area that can be used for installation layer A. We made the Incheon coastline through creating line layer and expressed the area vulnerable to salt damage through the buffer function. The assumed R value is 300 meters. We visualized the areas vulnerable to floods by buffering the habitually flooded area. The value of R is 150 meters. Furthermore, regarding the risk of fire, we excluded the areas near gas stations. We created a new layer by buffering the existing gas station coordinates to contain it in the negative area. We united 3 layers previously created using the union tool. Then, for the creation of layer A, which excludes negative areas, we used the difference tool to the united layer with Incheon City. The second area to be represented on QGIS was place that is installable, easy for utilizing, and in high demand for charging stations. We will name it Layer B. Through geocoding, the road name address of the public parking lot in Incheon is converted to the latitude and longitude coordinates, and the CRS is modified to be displayed. After that, the shapefiles of industrial complexes and residential complexes are also displayed. This is a picture of overlaying the three layers we created right before on layer A. Each overlaid on layer A, we could express layer B by using intersection function. Now we are going to create layer C, which is an area that lacks charging station infrastructure. We buffered each node selecting the R value 500 meter, which represents pre-existing electric vehicle charging stations. After that, we used the difference tool on the buffered layer with Incheon layer, so that we could obtain layer C. This is a visualization of the final position using layer A, B, and C. Layer D is the intersection of layer B and C. It is the area that needs charging stations first and foremost. Layer E is the exclusion of layer D from layer B. It is the second priority zone for installation. This is the picture of the expanded area that we earned at the last. The picture shows road data with changed colors. Dark blue color represents the most preferred place, which is layer D, and the sky blue color is the less preferred place to install charging stations, which is layer E. To sum up, by 2025, we suggest adding 4,436 charging stations in Incheon City in base of 2 priority area. I will include our project by presenting the limitations and better research plans that our team has learned during the project. First of all, information on state-owned and private land was not apparent. Secondly, grounds for selecting R values in buffered were not sufficient. Additionally, various data on electric vehicle charging stations were not provided enough, and the traffic data we had was too rough to be used. For the biggest limitation of the data utilizing phase was that traffic data lying on the road data had not been used. It was only used for distributing charging stations for each district. If the project had been proceeded based on raster data, we could have reflected the traffic data in our project. Thank you for listening.